Have you ever wondered about the true appearance of the Brachiosaurus in Jurassic Park? Despite being an iconic dinosaur, the animal's appearance in the film is not based on the Brachiosaurus genus. In fact, the true story behind the Brachiosaurus's appearance is fascinating and dates back to the early 1900s when these animals were first discovered. Join me on a journey through time as we explore the origins of the Brachiosaurus genus and the discovery of Brachiosaurus bones in Tanzania, and the controversy surrounding the genus's classification. It's time to unravel the mystery of the Brachiosaurus's true appearance. To understand how the Brachiosaurus's appearance in Jurassic Park differs from reality, we must explore the origins of the genus. The Brachiosaurus genus is based on a partial postcranial skeleton discovered in the valley of the Colorado River near Fruita, dating back to the late Jurassic period, approximately 154 to 153 million years ago. Elmer Riggs and his crew from the Field Columbian Museum, now the Field Columbia of Natural History in Chicago, discovered them in the Bushy Basin member of the Morrison Formation. The full type species discovered was known as Brachiosaurus altithrax in 1903, with Brachiosaurus meaning arm lizard and altithrax meaning deep chest in Latin, referring to the animal's unusually deep chest cavity. The Brachiosaurus's appearance in Jurassic Park is not based on the true appearance of the genus. The animal depicted in the film is based on a different genus, which is a different story altogether. The true appearance of the Brachiosaurus is interesting, and is most important to understand the animal's history and to appreciate its majesty fully. The holotype of Brachiosaurus was once fully prepared, consisting of various bones, such as the right humerus, right femur, scapula, thoracis, and caudal vertebrae, ribs, and sacrum. However, the loss of material assigned to Brachiosaurus is rare and fragmentary, making it difficult to refer to due to its poor preservation or lack of overlap with known remains. It is possible that the rarity of Brachiosaurus in the Morrison Formation could be due to other preservation biases or ecological factors. Despite their large size, not much is known about them. In 1906, a mining engineer named Bernhard Sadler discovered an enormous bone protruding from the ground at the Tenguru Hill near Lindi in German East Africa, which is now Tanzania. He reported his findings to his superior, Wilhelm Arnig, which led to further investigation by paleontologist Eberhard Froese in 1907. According to HUD, researchers were able to confirm the identity of a dinosaur as the Tenguru Formation. This era was full of fossils, and a large expedition was undertaken in 1909 to 1912 to excavate and describe them. The expedition resulted in many fossils being shipped back to Germany, undervaluing the native people who contributed to the excavation. This is an example of the many stains in history where colonial powers undervalued their colonized areas. The expedition unearthed many large bones belonging to one apparent taxon, which was later named Brachiosaurus bronchi bahaguna janak in 1914. The discovery of 3 skulls was particularly rare among sauropods. At the time, the remains of the largest specimen were believed to be the largest known dinosaur, but they were actually consistently outsized by the Titanosaurus relatives, which weighed up to 60 to 80 tons. The remarkable preservation of the eulithothorax in the United States allowed for a greater understanding of the genus as a whole, including its appearance in life and proportions. This made it an ideal representative of the genus in books and films. However, some researchers doubted the validity of a new species due to perceived similarities with another. Richard Lowell first voiced doubts in 1919, suggesting that the species of bronchi may not belong to the genus. Despite being largely ignored in scientific literature for almost 70 years, Gregarious Paul brought up the discussion again in 1988. With more specimens available for examination, Paul noticed observable differences in the skeletal reconstruction of B. bronchi compared to LC thorax. He identified differences in the corridors of the humerus, scapula, ilium, femur, and other elements, but noted that the most significant differences occurred in the dorsal column and trunk. In Paul's examination of the dorsal column of the LC thorax, he discovered that it was considerably longer compared to the femur of bronchi, and the newer arches were also longer and taller in Alcorithorix. He attempted to differentiate the two species, but the incomplete list of remains from LC's thorax made it difficult. Instead, he suggested separating them out to the subgenetic level, giving the species the name of Giraffatitan, essentially Brachiosaurus in brackets, Drapatus, and Bronchi, leading Titanic giraffe. However, this idea was not widely accepted due to the cumbersome and unreliable nature of subgenera in dinosaur taxonomy. In 1991, George Olszewski proposed elevating the name of Giraffatitan to a full genus level, but it was largely ignored. It wasn't until 2009 that paleontologist Michael Taylor challenged Paul's earlier statements about the bones of animals are similar. Taylor noted that the bones differed in practically every aspect, including size, proportion, and shape. He also pointed out that the dementia originally referred to in African specimen to the American genus was not convincing enough to separate them in the present. This shows how the field of dinosaur taxonomy has become more rigorous over time. From a distance, the bodies of Brachiosaurus and Giraffatitan are easily distinguishable due to their distinct physical characteristics. Brachiosaurus has 23 more dorsal vertebrae series and a taller, longer tail, while Giraffatitan has a more compact body with a shorter tail, but is generally taller. Brachiosaurus also has a more robust humerus bones, indicating that they may have carried more weight on their forelimbs than their Giraffatitan counterparts. In terms of body proportions, Brachiosaurus has more even shoulders, longer, bulkier limbs, and more robust neck bones. Additionally, their skull shapes differ, while Giraffatitan having a highly curved crest and short snouts, while Brachiosaurus has a more elongated snout with a less dramatic swoop to the nasal region. Edison, an intriguing Brachiosaurus specimen, has a surprisingly broader head compared to its bulky physique. This characteristic, along with the known skull structure of Brachiosaurus LC thorax, indicates that larger, more mature Brachiosaurus individuals could have had proportionally bigger mouths, as seen in other sauropod species. This fascinating discovery is part of a broader revision of the Brachiosaurus group, which also includes the reclassification of 3 other species. 2 of these have been moved to a separate genus named Lussotitan. These reclassifications highlight the significance of meticulously examining and reassessing older fossils to enhance our knowledge of prehistoric species. It is a continuous process that is likely to persist well into the future. As we continue to examine new discoveries and learn more about prehistoric life, we may discover even more surprises, and our understanding of the past will continue to evolve. As we come to the end of our exploration into the true appearance of the Brachiosaurus, it's clear that this iconic dinosaur is even more fascinating than we originally thought. From its discovery in the early 1900s to its appearance in Jurassic Park, the Brachiosaurus has captured the imaginations of people around the world. But as we've learned today, the Brachiosaurus we see in the movies is not the same as the true appearance of the genus. And that's a wrap. Remember to like, share, and subscribe to our channel for more fascinating videos like this one. Until next time, keep exploring and never stop learning.